Good. So we are handling the paper that we had yesterday, which is the paper of April 2022. And we are beginning with question number 3. Beginning with question number 3. Beginning with question number 3. The question says that random sample of 350 invoices issued by a RIG Limited revealed an average invoice value of $38,780 with a standard deviation of 8750. You are required the interval within which the population mean will fall at 95% confidence, level of confidence. I told you when you read these questions from sampling theory, the first thing is to know whether the question is hypothesis testing or the question is confidence interval. Now, this question is on confidence interval. The question is on confidence interval. That is what we are told to get. Confidence interval. Confidence interval. I told you after identifying whether it is hypothesis or confidence interval, you establish whether the population is known or unknown. Now, this one is unknown population. It is unknown population. And it is unknown because what we are given is the standard deviation of the sample. Is the standard deviation of the sample, but not the standard deviation of the population. The next thing that you need to identify is whether you are dealing with a single sample or 2 samples. And you can see the question says random sample. And if it's a random sample, then that means it is 1 sample. It's 1 sample. And then the next thing is to know which parameter you are being told to analyze. And I told you there are 3 parameters. There is the proportion, there is the mean and the variance. But for your syllabus, it is mostly the mean and the proportion. And then I told you that that one is obtained from the question statement, which you can see in Roman 1 saying, the interval within which the population mean. So that means we're analyzing the mean. So we will then come here and say, this is a case of single mean. It's a case of single mean. So that is how you identify the question that is at hand. You don't have to write all these in the exam, but it must be in your head because it is the one that will guide the formula to use. So having identified that, the formula is then given as X bar plus or minus T 1 minus alpha out of 2 n minus 1, you multiply by S, which is divided by the root of n minus 1. Which is divided by the root of n minus 1. So with that now, the mean is given as 38,780. So 38,780 plus or minus T 1 minus 0.05 out of 2 I told you alpha is what remains for the confidence level to be 100%. Then you say n minus 1, the sample size is 350. So 350 minus 1, that is the sample size. Now this one you multiply by the standard deviation, which is 8,750. You divide by the root of 350 minus 1. 350 minus 1. So this becomes 38,780 plus or minus. Now take your papers. You go to the T tables. And when you go to the T tables, you remember we normally say on this side, you go to where you can see two-tail confidence, where there is that hanging whatever, two-tail confidence. And then you move towards the left-hand side, where you have 95%. Then you go downwards to this one, 349. And you realize that the table at hand has gone already up to 30. So I told you, if you are dealing with a figure that is outside your table, you go with the highest value in the table. So the highest value is 30. So we are going to get this from two-tail confidence, 95 and 30. What do you have? 2.0423. So this one you multiply by 8750, which is divided by the root of 349. So we proceed and say that 38,780 plus or minus, work out that and give you the answer. Nine? 956. So we can make it 957. Let's make it 957 to avoid decimals. But in the exam, it's advisable you use the decimals as they are, at least 3 of them. So subtract. Give me that 7. 823 is less than or equal to mu, which is less than or equal to, add now. It's 39,797. So that is the confidence interval that the candidate was supposed to provide to the examiner. Roman 2, they are saying the sample size of invoices that would result in a 99% confidence level of interval obtained above. So what we shall do is we can use the upper limit. using upper limit, using the upper limit, using the upper limit, that is 39,737. How have we arrived at that 39,737? We have arrived at it by adding these 38, 780, 780, multiplied, rather, we have added these 957. So how did we get the 957? The 957 was arrived at using these 2.0423. How did we get that? That one we had gotten it as T1 minus 0.05, but now in this case it is not 5. We are using 99%. So it is 0.01. We divide it by 2. Then we say n, which we do not know, minus 1. N is the one that we are told to look for, minus 1. Now this one was multiplied by, 8750, which was divided by the root of n minus 1, which you do not know. Now, this equation as it starts, is not solvable. Why? Because it has two unknowns and it is one equation. This value here, the 2.0, is unknown. Even this one is also what? Unknown. So those are the two unknowns. But nonetheless, we must give the answer to the examiner. So what do we do? What we do is we know that this value will not be far away from the original one that we had of 350. So at least we know this value will be at least greater than the highest value of our table. Our highest value of table was 30. That's all. So go to the table. You go to the table. And when you go to the table, you'll be able to say, we do not know n. We do not know n. But we know it is, the alpha is 0.01. So that is 99. So tutaenda tu pale mwisho kwa two-tail confidence. Then we move back, or rather we move to the left-hand side and stop at where there is 99. Are you there? So if you have stopped at 99, then uteremuke all the way to 30, and then we read that value. What is that value? Yes, you go to where there is 99. I can see 2.75. Yes. So that 2.75, at least now it has solved our problem of having two unknowns. So this is unknown. And now we have known it. So now we are left with this one. We are left with this. So tutaendelea kusema Now this is times 8750, which is divided by the root of n minus 1. The root of n minus 1. Now from there, I believe you can be able to deal with n minus 1. So you can be able to solve n minus 1. Yeah, so first of all, you can say that 9737, you minus 38780 is equals to 2.75 times 8750. You divide by the root of n minus. So solve and give me the value of n. I'll sort out something out. So what is the value of n from there? The value of n. Babanan, give me the answer. What's the answer? How do you solve for n? Yeah. You have no answer, my good friends. Sasa, give me this difference. 957. Sasa hata unafanya niandike transpose. 957. Yes, Mercy, I can see your answer. Good. Umesema 957. Multiply this. 0.62.5. You divide by the root of n minus 1. So you multiply everywhere by n minus 1. So that you have 957 multiplied by the root of n minus 1. You unaachwa na 24,062.5. Ukishafanya hivyo, you divide. You achieve the root of n minus 1 is equals to 24,062.5. Divide by 957. If you want to be left with the n on its own, you get this, you square everyone. You achieve n minus 1 is equals to 24,062.5. Divide by 957. You square this. You square that. Then you tell me n should be equal to 24,062.5 divided by 957. You square, then you minus 1. Not you minus, you add back. You add. Six that 3.2. Good. So Mercy was right. That is good. These things are very simple. Unaenda tu pole pole, step by step. Na finally unafika. Afura, now are you okay? Good. Let's proceed to the next question. That says the following information relates to the operating life of two brands of mobile phones, brand A and B. Mean life, standard deviation, sample size. Now advise a potential customer on whether there is any significant difference between the quality of the two brands of mobile phones at 5% level of confidence. So again, that question is from sampling theory, the topic of sampling theory, and you need to know whether the question is hypothesis testing or confidence interval. Hypothesis testing or confidence interval. What do you think? I'm at a sampling theory. Say the question has come from the topic we called sampling theory. And I told you sampling theory is divided into two areas: confidence interval and hypothesis testing. How you know what is required, again, is by looking at the question statement. And question statement is the sentence that has the question mark or the question that follows the word required. Looking at that sentence, you can see we are being told whether there is any significance difference. So hypothesis testing is the test of significance. So this is hypothesis testing. The question is hypothesis testing. Then here below, we do the other identifications. The other identifications are one, whether population is known or unknown. So is this population known? Let me see. Is this population known? Type yes or no. Is this population known? I have no idea. Yes, Wafula, good. Yes, Masi, good. The population is unknown. The population is unknown because you can see what we are given is the standard deviation for the sample, not for the population. The next thing is to know whether you are dealing with one sample or two samples. So are we dealing with one or two? Two, good. And then the next thing is to know, are you comparing, or is the question about the means or the variances? Again, from the question statement. Is it about the means or the variances? Yeah, it's about the mean, because if you're buying the phones, your concern as a customer is the mean lifetime the phone will serve you. So if there are two, I told you we talk of means difference. Means difference. We are looking at whether there is any difference between the two means. Whether there is any difference between the two means. Now, in that case, the journey begins by developing the hypothesis. And I told you, for exam purposes, you take it this way, that in the null hypothesis, the first mean is equal to the second mean. That is, the first one is 1730 and 1684. 1730 is equal to 1684. That is how you put the null, meaning there is no difference. Then the alternative is stated, you now look at this one, whether it is greater than this or less. So as you can see, x1 is bigger than x bar 2. That is 1730 is greater than 1684. It's greater than. Now from there, the next thing is significance. Significance level. And significance level, we are already told to do at 5%. So alpha is 0.05. 0.05. The next thing is to tell us the test statistic that you're going to use. The test statistic that you're going to use. And here we say we use T, which is given as x bar 1 minus x bar 2. And this one is to be divided by the square root of n1 minus 1 s1 square plus n2 minus 1 s2 square. Now all these you divide by n1 plus n2 minus 2. You get it into brackets. Then 1 out of n1 plus 1 out of n2. And this one now, we are supposed to get the square root. Supposed to get the square root. So with that, you now tell us T calculated will be what? Now the T calculated will be 1730 minus 1684. Now here, we are supposed to divide by n1. n1 is 200. So 200 minus 1 multiplied by standard deviation 102 squared plus 108 minus 1, you multiplied by, no, this is 200 and 2 is 200. So 200 minus 1, you multiply by 108 squared. Now this one, you divide by 200 plus 200 minus 2 minus 2. Then you say times 1 out of 200 plus 1 out of 200. So you get the square root of the denominator. You get the square root of the denominator. So solve that and give me the answer. So as you solve, after you solve that, we will also take a break for prayers. Good. So now give me the figures. What have you gotten? 4.379. Someone else to confirm the figure or dispute? Yeah, good. Christine confirms. So we go by that now. So the next step is the decision rule. And this decision rule is what we call one tail. Is one tail. And the degrees of freedom will be 200 plus 200 minus 2. That is 398. Those will be the degrees of freedom. Alpha, we already know it is 0.05. So with that, we design the rule. Design the rule. So here we have X bar. Now X bar is, we may not need to define the X bar. We may not need to define that. What I need is the critical value. So because we are doing the upper side, so here I will have a positive T critical. And this side now, if I find myself up here, if I find myself up there, I will say it is reject null. And remember the percent is 0.05. But if I find myself anywhere here, I will advise we accept null hypothesis. So go to the T table, unisome this value at 0.05. Remember, this is one tail, so you've got one tail confidence. One tail confidence, and then you move backwards to 95. Uteremuke mpaka kwa 30, because this one is beyond 30. 1.6973. 1.6973. So from there, we come and make the conclusion. Come and make the conclusion. And the conclusion that you can see here is we should do what? We should reject null hypothesis since T calculated is greater than T critical. That is 4.379 is greater than 1.6973. Then you tell us the meaning. The meaning is the question had asked us to test whether there is any significant difference between the quality. So we'll say there is a significant difference. There is a significant difference between the quality of the two brands of mobile phones at a 5% level of significance. So that means the phones are different. They're not the same. Phones are different. They're not the same. Good. Read the next question. So if you have read the question, you can see it is also on sampling theory. And it is hypothesis testing. It is hypothesis testing, the test of significance. And the other thing that you can see is that it is what we call chi-square. It is what we call chi-square tests. The chi-square, which is written like this. Now the chi-square the first thing is hypothesis. Hypothesis. Now, in the hypothesis, the null, I told you in chi-square, it is always stated as there is some association You can leave it at that point, or you can tell us association between who and who. Like now in this case, there is some association between the two strategies. You just leave it that way. In the alternative, we say there is no association. There is no association. The next thing is to get the significance level. Significance level. Now here alpha is 5%. I think the question has not specified the percentage. So we are going to do with 5%. I think is our paper has a typing error. That's why the most likely it is omitted. The next thing is test statistic. Now, test statistic chi-square is given as sum of F naught minus FE. You square this, you divide by FE. That is how we get the chi-square. And we said, from there now you prepare the table of expected frequencies, or rather observed. You start with observed. Observed frequencies. That is the F naught. Now, in the table of observed frequencies, we have two strategies here. So the strategies are K, we have P, and we have total. Then we have those who won. It is 130. It is 110. If you add, this will be 240. So then we have defeated. Defeated is 20, 30, that is 50. We have those who drew. This is 60, this is 50, so this is 110. And then we have total, this is 150, that must be 210. This is 140, that is 190. And this must add back to 400. Add back to 400. So then from there, we can prepare the analysis table. The analysis table. And this analysis table, it has observed frequency, This is F naught. I hope so. This is the share. Then we have expected frequency. And the expected frequency, I told you, is given as row total multiplied by column total. You divide by grad total. That gives you the FE. Then you will get F naught minus FE. I think we can, to minimize the columns, we can just square straight. Can square that straight instead of having two columns. And then we will have this F naught minus this F2, which is, we can even actually have it as one column instead of creating umechora the last one. Instead of creating another one here, because now tuko na kila kitu, we can just come here and say this one you divide by FE. Yeah, that one. Instead of creating another column, because we have everything that we require. So this is 130, 20, 60, 110, 30, 50. There were even 6. I don't know why I was thinking they are 9. Okay. So let me frame, then I'll leave you to work it out. When you come to this one, according to a formula, you get the row total. The row total is 210. Column total is 240. You divide by the grand total of 400. Then you come to this one. The row total is 210. Multiplied by the column total, which is 50. You divide by the grand total of 400. When you come here, row total is 210. Column is 110. Total is 400. When you get here, the row total is 190. Column is 240. You divide by 400. When you get here, row total is 190. Column is 50. You divide by 400. When you get here, the column is 190 multiplied by the 110. You divide by 400. And the total here, look here, the total must add back to 400. And these three, I don't know whether they will be giving us decimals. If they will be giving you decimals, let me explain, because that's the general concept. These three here, they must add back to 210. So if there will be decimals that will make it round up or down, because I want you to work with whole figures. If there will be decimals that will require you to round up or down, the third value here, it will be 210, you subtract the first 2. The same case ukikuja hapa kwa these three. The third value will be 190, you subtract the first 2. So that now the 6 values will add exactly back to 400. So, twende kazi. You're through with this column?
Yes.
What's the report? 26.25. Okay, 26.25 then. Okay. So you may not need necessarily to have the same figures because of the roundings, but what we say they must add back to 400. Okay? Yeah. So now work this and then you give me the total down here. So what is the total here? 3.588. Someone else to confirm that top? Yeah, 3.585 or 88. Good. So now from there, that was so now you come here and tell us chi-square calculated is 3.588. Or if you have gotten a different one, you write yours there. You have gotten a different one, you write your value there. So in the division rule, this one for the chi-square, we will not keep on drawing. What we shall do is, first of all, to get the degrees of freedom as row minus 1 multiplied by column minus 1. The number of rows, you less 1. So if you look at our table that we have drawn, this table here, it has 2 rows. So 2 minus 1, and it has 3 columns. So 3 minus 1. So this is 2 times, this is 1 times 2, so the degrees of freedom are 2. So the chi-square critical, you will need to go to where we have the chi-square table, and you look for 0.05 from the 5. So that's why we have 0.0 something. Yeah, 0.05, and you go to row number 2. The degrees of freedom, there are 2. So that gives us what? 5.99. 5.99. So with that, you make the conclusion. So the conclusion will be to accept the null since you accept the null since chi-square calculated is less than chi-square critical. That is 3.588 is less than 5.99. Is less than 5.99. And then you tell us the meaning. When we say we accept, we had said there was some association. So you tell us there is some association. There is some association between the two strategies. P and K, or K and P. There is some association. So are we okay with that? Good. So if we are okay, then we will have to stop at that point. As I can see, time is spent. We may not be able to finish question 4. So we can pick up from there. in the next lesson to handle question 4. So thank you. See you tomorrow, God willing.